Hello everyone, my name is Victor Mathias, and my project was about how can clean energy be used in entry-level engineering projects. Myself, I'm a student of middle college. I went to Northwest High School, and I study general engineering. Starting off with why I even chose this topic in the first place, well, if you look at the world today, as energy consumption grows, climate change has become an increasingly more present issue. 80% of the world's energy usage comes from fossil fuels, which emits toxic gas into the atmosphere, and also are not renewable, so they will run out eventually. One of the main efforts to limit this effect is to switch to something like renewable energy. Some benefits of renewable energy and why it can limit the effect of climate change is because they're reliable, since they will always appear, the sun will always shine, and the wind will always blow. They limit carbon emissions since they have no emissions whatsoever. They create jobs because you need people to work the farms and to create the farms. And they also diversify the energy sector, which is an incredibly important issue since if one energy sector collapses, it's incredibly important that we don't have an energy catastrophe. You can see on the graph some common forms of energy, how it's obtained, and it's sorted by the method. You can see, maybe you can't see, but it's listed here, that hydropower accounts for 6% of energy in the world, wind accounts for 3%, solar for 2%, and biofuels for less than 1%. So you can see that although these percentages are very small compared to the entire energy sector today, renewable energy is on the rise. And by 2050, solar energy alone will account for about 30% of the entire market. Switching gears into how learning translates to work, everybody knows that the main purpose of school is to prepare students with the sufficient knowledge for their work in the future. Things like the books you read and the experiments you do are done to model exactly what you're going to do in the work. Therefore, these practices you create and the habits you create are going to translate to your work. And in entry-level engineering classes and other classes as well, they utilize wasteful energy methods like alkaline batteries and ignoring effects, which, although it's small, it does create the effect of sort of ignoring the effects of wasteful energy. Looking at these two together, you can see the obvious gap between them. The future of energy, which will rely on renewable sources, does not equal the lessons being taught in class. Allowing students to utilize clean energy can better suit them for their work in the future and also educate them on the importance of clean energy, which can have more people understand it and more people fight the effort of climate change. So my goal with this project was to find that common way to implement clean energy into engineering projects. I wanted to find an exact way to do it. And in particular, I decided to use solar energy using a solar panel. The reason being is that these are by far the most accessible for home use and school use because they're cheap. They're about $20 on Amazon, maybe even cheaper. They're small, so you can hold them in the palm of your hand, and you can even use them in any project. And for that size, they're very efficient. They have enough voltage to deliver for a whole project. For how I went about this goal, I needed to ask myself the question first. What project am I even going to try to make? So to answer this, I needed to analyze my target demographic, which was high school students and college students in their first years of classes. And looking at it, in MCPS, all students are required to take at least 1 year of technology education. This can come from coding, engineering design, foundations of technology, and more. The types of these classes are found in high school and in the college level, and they're open for all types of students, not just STEM students, so more people can learn what they have to offer. And looking at what they actually do, going through it myself, their main purpose is to create working projects using small pieces of technology. And one of the most common pieces in these classes is something called the microcontroller. And what the microcontroller is, it's a central hub for any sort of electrical project or circuit. It directs currents in and out, and most importantly, it allows for code, so you can have these parts around it working in tangent, and you can create a whole project just centered around this one piece of equipment. And by far the most common one is something called the Arduino, which is pictured right there, and that's the one I decided to use for this project. Some benefits of the Arduino is that they're cheap. The prices start around $20 US for the smaller ones and 40, so you can purchase them from retailers and they can be bought by schools. They're compact. The one that I used was one of the larger ones actually, and it's only about the size of a small sponge, but you can get smaller ones the size of maybe a USB stick. They're safe with only a 5-volt operating voltage, so you can tinker with it and do whatever you want without the risk of shock. They're easy to use, so beginners can just tinker with them and do whatever they want, and they're also open to children. And then obviously they create endless possibilities with the parts around it by being the center of it. Now that I chose my center for the project, it was time to figure out what I actually wanted to do exactly. But searching for projects online was not very helpful. Many of the projects were either too niche, too simple, or just not very useful at all. So to go about this, I had to go to my own personal catalog. And as an engineering student myself, everybody goes through the class ENES 100, which is the first engineering class you ever take. And one of the main projects you do in this class is something called the Doodlebot, which is really just a car that can move on its own and draw doodles using a marker. I chose to do this project because it features that Arduino module, although that's not an Arduino exactly up there, you can easily use one. And it's done by real entry-level students, since that's the main goal of my project. You can implement it immediately. I chose to modify some things about the project. I took away the doodle aspect. I didn't want it to be able to draw since that's not really the main point of the project and it's too janky to work with. I made it remote controlled since I prefer having live input rather than predetermined code. And I also made it solar powered, obviously, to achieve the goal of clean energy. For what I actually did for the car, I'm going to give a list of everything that was used, but you don't have to remember any of it. I just want to give you an idea of the types of parts that I used. So you can see the final project here. The first thing I used was the base. It's an aluminum base. I then used 2 continuous servo motors on the bottom here. I can't really turn it upside down, but they look like this individually, and they just spin the wheels. And speaking of the wheels, they attach to the servo motors and spin with them. I then used specifically a Mega 2560 for the Arduino, but you can really use any type. It's a pretty simple project, so you don't have to go out and get the highest end one. I also used a mini breadboard, which doesn't really have a whole function for the project, but it acts as a blank canvas, so I could use more wires and have more space. And then for the remote controlled aspect, I decided to use infrared light using the remote and a sensor right here. That's the remote, and that's what the sensor looks like by itself. The solar panel I decided to use was 6 volts, just standard 6-volt panel. The reason I chose this one was because it fits comfortably with the 5-volt operating voltage of the Arduino. And then these ones I'm not going to get too into because I'll get into it later, but I used batteries, a charging module, a boost converter, and a diode. And like I said, I'll get into those later. As for the physical build of the car, it's fairly similar to the way it was originally intended. The base, the motors, and the wheels are actually found from a bucket in the class. So these were real parts that were used in the actual project. I then attached the breadboard and Arduino right on top of it, so it's smack dab in the center, allowing it to be, that center module, and I could access it at any point. I also taped standoffs, which there's 3 standoffs here. I just taped them together to give more height. And then with these standoffs, I put some cardboard right on top, and then I was able to have like a second level for the solar panel to have access to light and the IR sensor to have access to the light that needs. For the electronic configuration, there's only 3 total connections you have to make for this whole project. The first one is to connect the servo motors to the Arduino module, and each servo motor has 3 connections that need to be made: a power, a ground, and a signal. Now, since each servo motor needs 1 power, the Arduino only has 1 slot available, which is why the breadboard is needed. It acts as like just a hub, like a USB hub, where you can get more slots. And then that was done, so that's the first step. The next step was to connect the IR sensor in the exact same fashion. The sensor has the exact same pins, power, ground, signal, so I did that in the exact same way as the servo motors. But then connecting the solar panel, as you might be able to see from here, it wasn't as simple as just plugging it in and having all that work. So I needed to do something a little different. The reason that the solar panel needs more wiring with it is because it can easily fail to deliver enough voltage. If a solar panel is in the shade or if it's nighttime, it won't generate any power, and therefore the car will not move. And for me, that was just too inconsistent. I didn't want to drive it on the sidewalk and have it stop just because it's under a tree. So what I did was I researched how to solve this issue, and one of the most common ways is to take the energy from the solar panel, store it in batteries, and then use the energy from the batteries to power the Arduino. So the solar panel generates electricity, which goes to the batteries, and the batteries are used to power. The batteries I used in particular were just common AA batteries you can pick up from the store. They're 1.2 volts each, and they are listed as rechargeable, which you need since you can't recharge normal alkaline batteries. As for the coding, I'm not going to dive too deep into it since it's not the main point of the project, but I wanted to go over it a little bit. The first thing you had to do was initiate the servo motors and the IR sensor so that the IR sensor would be available to pick up light and the servo motors would be stopped. The next thing to do was to analyze how this remote actually remote controls the car. And the way that works is that this is the remote in close-up. Each button press on the remote emits a different amount of IR light from the tip of the remote, just like a TV. That light is then absorbed by the sensor and then transmitted to the Arduino through the wires. And inside the Arduino, it takes that signal and puts it into, and dissects it into a hex code, which is just a code with letters and numbers. And what that does is it allows each button to have its own identity. I can press this button and it knows it's that one. And then using that hex code, I could set the speeds of the motor accordingly. If I pressed this button, I could move this motor at whatever speed to make it go right or forward or back and such. For what were the actual results of the car, I wanted to go over the charging circuit in a little bit more detail. And this is actually a model of the entire circuit. Starting with the solar panel, photons from the sun get generated into electricity through the solar cells, and this electricity is then transmitted to the board, and the diode is used just to direct current in the way that I want. It's just so that I can make sure current doesn't go back into it. And then that current is then sent to the charging module, which is another sort of central hub for the whole circuit. It does a lot of the work for me, and what it does is it takes input voltage from the solar panel, it distributes that voltage to the batteries, and then takes the battery voltage and then distributes it out to the output. That's everything that I need to do. I don't need to do anything myself. The input voltage is anything around 4.5 volts, which the solar panel will account for that. The max charge for the batteries is 4.2 volts, so the max that these batteries will ever be charged in total is 4.2 volts. And going over the batteries again, when they're fully charged total, they have 4.8 volts, but they will only get charged to 4.2. And then the output, after those batteries are being distributed, it will go to something called a boost converter, which all that does is it takes the 4.2 volts from the batteries and the charging board, and it boosts it up to 5 volts perfectly, just for the Arduino. And what's convenient about that is it also has a USB on the end, so all I have to do to power it is just hook a USB cable up from the boost converter to the Arduino. As for how the solar panel actually worked, it varies by day and it varies by weather. All this data was taken in Germantown, Maryland, which does matter since the sun does change the strength as you go around the world. The mean voltage from the entire project was 5.33, and the mean voltage when it was only outside was 5.54. The reason I have this data point is because if you see on the 14th, I decided to test the limits of the solar panel, and I only kept it inside. I kept it in the rain. It didn't deliver enough at all, so I just wanted to note that, but I also wanted to separate that out since it is an outlier. The max voltage from all the days when it was fully sunny was 5.8 volts, and the minimum voltage when it was only outside was 5.04 volts. This fits well in the range of the 4.5 for the charging module, which means that as long as the solar panel is outside, no matter if it's cloudy or rainy, it'll always charge. The performance of the car, it has good and bad aspects, just like every project does. The responses from the IR remote are quick and accurate. Each button press will model on the car exactly, as well as the driving modes. If I press forward right, it'll go forward, right, and then all of that. The solar panel also successfully powers the Arduino, which is the main point of this project, since I wanted to have solar power the whole thing. And what was surprising is that it's also able to traverse various types of terrain, such as wood, grass, and also go over wires and such. For what could be improved, infrared light is very weak. It's on the lower side of the spectrum, so you do have to point it directly at the sensor, which makes it hard when it's facing you. And it also can't travel very far, but it's far enough. It's also slow because of the servo motors. These motors prioritize movement over speed, but if you wanted speed, you could use DC motors, which would decrease the accuracy of movement, and you would have to create an axle system. But overall, the car runs very smoothly. So in conclusion, and what I learned, it is possible to implement clean energy methods into entry-level projects. It can be done using simpler methods because although I had to solder and use a lot of wires, you can buy things like solar batteries and whole circuits like this just off Amazon, and then it would provide the same effect. And solar power on the Arduino can be a project in and of itself, as I just showed, and it can also be a demonstration for students on solar power. And if students have at least one project over the semester that can implement this type of clean energy, they can learn about the benefits, and they will also be better prepared for their work in the future. And they will also contribute to limiting the effort of climate change. Any questions?